going through the rules for integration. If you integrate sine, you get negative cos. If you integrate cos, you get sine. If you integrate sec squared, you get tan. If you integrate sine of ax plus b, you get negative 1 on a cos ax plus b plus c. They're the rules yesterday. If you integrate cos ax plus b, you get 1 on a sine ax plus b plus c. And if you integrate sec squared ax plus b, you get 1 on a tan ax plus b plus c. They were the rules yesterday. Now homework problems. Question 7. Which one? Cambridge. Question 7? A or B? Question, because you have to separate the curves. So I never got to this one yesterday. Cambridge, exercise 3H, yeah? Question 7A, I wanted to do this, but I never got to it. All right, did I not do this one? No. You sure? Good. Okay, find the shaded area. So question, you can just write your rules out later, all right, girls? So homework problems from last night, you have to, one of them's the sine curve, and the other one is the cos curve. Now, girls, when you're doing area, sometimes it's the area between two curves, or sometimes you've got to do the two separately. We've got the sine curve here and the cos curve there. We did this sort of thing yesterday. What is that point of intersection? Where do they intersect? Yeah, where does sine x equal cos x? Remember, we solved this yesterday by dividing both sides by cos. Do you remember? So whenever you've got sine x equals cos x, the answer is pi on 4. So divide both sides by cos. You get tan x is 1, so x is pi on 4. Now, if you want that shaded area, it is not the area between two curves. There are two separate sections. Here's the first section. That area is below which curve? It's got nothing to do with the cos curve. It's under the sine curve. Can you see that? So therefore, your area, shaded area, will be the area between pi on 4 and 0, the area underneath the sine curve, between the values of pi on 4 and 0, and the other area, see, sometimes, girls, when you look at the area, it's not between two curves. Part of it's under one curve, and part of it's under the other. Well, this other area over here has got to do with which curve? It's below the cos curve. No, it is symmetrical. You could times it by 2, but just be careful. Plus, it's the area underneath the cos curve from the values of what? Pi on 2 to pi on 4. Okay, if you're going to do that, you could say that these curves, one is just, you know, the sine and the cos curve are just translations of each other. One's just a 90-degree difference to the other. You could, but you'd need to say why. All right, that's okay. So now, integrate sine, what do you get? Negative cos. Pi on 4 and 0, plus integrate cos, and you get, what do you get if you integrate cos? Sine, normal sine, between pi on 2 and pi on 4. Now, yesterday what we were doing, I don't like substituting negatives, but look, I suppose we haven't got, you could pull this negative out and then do your substitution. Because otherwise you get negative that minus negative that. Look, it doesn't matter. You can just do it. What's negative cos pi on 4? What's cos pi on 4? All right, I won't pull it out. So it's negative cos pi on 4, which is negative. I'll write it out. Negative cos pi on 4 minus negative cos 0 plus sine pi on 2 minus sine pi on 4. So I'm doing all the working, and this time I didn't pull the negative out. What's negative pi on 4? Cos pi on 4. Negative what? What's cos of 0? Here, just have a little cos curve there and a little sine curve there. Sorry, my cos curve's really bad. Cos of 0 is 1 plus, what's sine pi on 2? No, it's not. It's 90. There's pi, there's 2 pi's. Sine pi on 2 is sine 90, which is 1. What's sine pi on 4? So, what have you got? Add the whole numbers. What do you got? Well, you've got 1 plus 1, you've got 2 minus 2 lots of 1 on root 2, haven't you? Which is 2 on root 2. Please, someone tell me what 2 on root 2 is. Because it's root 2 squared. Gloria, that's for you. 2 minus root 2 squared on 2, which is 2 minus root 2, because a root 2 cancels from the numerator and the denominator. And that will be units squared because it's area. So that's question 7a. I'm not going to do 7b, but we're going to talk about it. You would here, you could just say that basically the sine curve is a shift of the cos curve, and I suppose there's some sort of, yeah, and that there's, yeah, oh. Look, I prefer for you to do that when you've got area above, area below, or areas around the y-axis. Do you know what I mean? That's when I prefer you to do that. Now, another problem for them in the homework, have we got that down or not? I'll just pause. If you need it, you go to the video. So this one here, 7b, that was also set for homework. So you can shade this bit. There's one area under there. Now, you don't need to integrate that, girls. It's really easy to work out that area. How would you do it? It's a triangle. Half times the base times the height. Because that's 1 and that's 1. Half of 1 times 1. That area is a half. Your other option is to integrate the line x plus 1. Get x squared on 2 plus x. Substitute. What's easier? Do the triangle. So girls, you've got two areas. This triangle, which you can just do by area of a triangle. Integrating gives you the area under the curve. And what would you do with this one? Integrate cos between the values of pi on 2 and 0. So to do that one, I wouldn't integrate that, I definitely would not integrate that other one. Oops, here. I would definitely just do area is a half times the base times the height for the first one, for the triangle, plus the integral, is it pi on 2, that value? Now I'm really big here. Plus the integral between pi on 2 and 0 of cos of x dx. Your other option for that would have been to integrate x plus 1. But why? Why would you do it? This is so much easier. Half of 1 times 1. Who did this and integrated? I'm off screen. Who integrated x plus 1? Can you see? If you see a triangle or a semicircle, you actually can't integrate the semicircle functions anyway, the circle functions. You do area. Quadrants, do area. Parts of circles, use area formula, pi r squared. Alright? Straight lines, triangles, use area. Okay? So you'll finish that off. You okay? Integrate cos, you get sine. I'm sure you can finish that off. And what do you get? A half plus, what's sine of pi on 2? Minus sine of 0. Sine of pi on 2 is what? plus, isn't it that? The answer is 1.5 units squared. Okay? So that was easy if you decide to use area formula. All right, we're going to do some more questions from exercise 3H. I want to do some from 3G, and then I can set some textbook stuff or whatever, or we go straight to HSC questions maybe instead of the textbook. Bit of a waste of time. All right, question. All right, we'll work through a few of these together. Do we want to do let's do one from question 8. All right. Yeah, the gradient function. This is exercise 3H, question 8a. The gradient function of a curve is dy dx equals sine x if the curve passes through the origin. Find its equation. I'll make this bigger. I'll pause the video, have a go. Do you think you know what to do? Not putting on a song and dance. Right. Girls, this question, that's the gradient function. Whenever you've got the original function y equals, you differentiate it to give you the gradient function. Now, if I've got the gradient function and I want the original, what do I do to it? Good. That's right. So y is the integral, the y function is the integral of sine x dx, which is what? Integrate sine negative cos x plus c. That's what y is. Now what do I do? Good. We're just working out what c is. Sub in the point 0, 0, which is x is 0, y is 0. We get 0 is negative cos 0 plus c. We do a little sketch of cos curve there. What's cos of 0? So it's negative 1 plus c. c is 1. Therefore, your function is y equals negative cos x plus 1, or it's 1 minus cos x. Explain what that curve looks like in terms of curve sketching. So you start with the normal cos curve. What do you do to it? You reflect it in the x-axis, and then you shift it up 1. Beautiful. Okay. Question 9b, find the exact volume of the solid formed when y equals the square root of cos 4x is rotated about the x-axis from x is 0 to x is pi on 8. It's not too bad. Like the cos curve looks like that. Isn't this 2 pi, pi, pi on 2? I mean, the pi on 8 business, it's all in here. And if you square root positives, your answer is positive. In other words, you don't really need to know. The curve's going to look similar to that. But anyway, it's going to be positive up here somewhere. It doesn't matter. But it's getting rotated about the x-axis. So what do I do first when I have these volume questions? I write the formula. Volume is pi b on a y squared dx. Rotation about x-axis is y squared dx. What does y squared equal? Yeah. So you write y is square root of cos 4x. Y squared is cos 4x because it's square root squared. So it's just integral of cos 4x dx between the values of pi on 8 and 0. And you can do it times 1 on 4 sine 4x pi on 8 0. Really, pull out that quarter to the front and make it what? Instead of just pi, make it pi on 4 at the front. And then we've got sine 4x and you're substituting pi on 8 and 0. So you get pi on 4. What do you get? Sine, what's 4 pi on 8? Sine of what? Minus sine of 0. Pi on 4. What's sine of here? Little sine curve. Sine of 90. Sine of pi on 2. what is it? 1 minus? So it's basically pi and 4. Units cubed because it's volume. Those aren't hard. Yeah, but we need to do some harder ones over the page. They're not even development. All right, let's do some. That's your window, arch window, 3 meters high. It's just that we could give you questions like this with wording. Could be towards the end of the paper. We may not have the drawing. We listening? Question 11, an arch window that's 3 meters high and 2 meters wide. Notice they're putting it around the y-axis. There's 0. And put 1 meter that way and 1 meter that way. Make it symmetrical about the y-axis. It has this, it's in the shape of this curve, y equals cos pi on 2x. Find the area of the window. Tara, how would you do this one? Seems you want to double up on things. Go. Question 11. Yes, good. See, this is symmetrical. For this one, you would definitely do 2 times the integral from 1 to 0. Do you get it? Of that function. We can try it. Do you want to do it? All right, have a go. Can you do that question? So, I'll just pause for a sec. Let's look at question 12. Oh. Do you know what to do with question 12, girls? We should try one of like 12b. Do you want to do 12b now? Or you think it's similar to that example I did before. First derivative's that, function of 0 is that. Do you know what to do? What would you do? Don't do it yet. Just tell me what you'd do. What would you do? You would integrate it. Substitute in. When x is 0, y is that. Work out your c. Once you've got the function, they want function of 1/6. Do we need to do it or not? You've done stuff like this before. I will set one of those for homework. Which one? B. Right. If you're not sure what to do, go back and listen to the video. Yes. Do you want it? If you want, for C, you would integrate twice. All right? If you want, you can do C. 13. I think they look 14, all of it. 18. No, just by substitution, in other words, put x is negative pi and 2 into that, and x is negative pi and 2 into that. Do you want to do that one now? We can. Copy and complete. 1 plus tan squared x is equal to what? Good. Hence, find the integral of tan squared x. All right, girls. I think you're okay with those other questions. So it says 1 plus tan squared x equals sec squared x. How would you then find the integral of tan squared x? Isn't it the same as, what does tan squared x equal here if I make it x? Yes, from 2 unit. So 1 plus tan squared x is sec squared x. What's tan squared x there for? Sec squared x? Good. So if you want to integrate, girls, tan squared x, you actually integrate sec squared x minus 1. Do you get it? Okay, so if you're ever asked to integrate tan squared x, that's what you would do. Yes. What's the integral of sec squared? Yeah. And what's the integral of 1? Plus c. That one's done. You're going to do b as well. I don't think you can do b. So we're doing question b. It says simplify 1 minus sine squared x. This is 2 unit, not 3 unit. All right. Where have you seen sine squared x and 1? There is, you know how 1 plus tan squared x is sec squared x? There's another one. Sine squared x plus, what's the rule? Cos squared x plus sine squared x is 1. So if I do 1 minus sine squared x, what does that equal? Good. So I'm trying to do 1 minus sine squared x. That's the same as cos squared x. So it says simplify 1 minus sine squared x, which we've done. Hence find the value of integrating between pi and 3 and 0 of 2 over 1 minus sine squared x dx. Yep. Here's the question. Hence integrate that. What does that? You can't integrate this, so you've got to do what that's the hint from there. What do I replace the 1 minus sine squared x with? Because it's 2 over. So they said 1 minus sine squared x is cos squared x, hence find this integral. Well, you can do 2 over cos squared x. You still can't integrate that, girls. I haven't shown you how to integrate 1 on cos. But what does 1 on cos equal? You can't integrate it. No, it won't even work with logs. No. Girls, what do you know how to integrate? Sine, cos, and sec squared. That's it. What does 1 on cos? Isn't it sec? So, what's that? 2 sec squared x. 1 on cos is sec. 1 on cos squared is sec squared. Are we good now? Between pi and 3 and 0. So girls, these aren't difficult. What's difficult about these is recognizing what they want you to do. The actual maths is not hard. But girls, the hint in the first row gives you that hint with what to do. 2 on cos. See, girls, if this is a 2-unit paper, you've got to think, I only know how to integrate sine, cos, sec squared. If they're giving me something else, I've got to make it into something I know how to integrate. So, sec squared, what do you get? Yep. You could put the 2 out if you want. Tan of pi on 3 minus tan of 0. Yeah, tan 60, that's the big one. What do you get? And tan of 0 is? It's not 1 on root 3. So the answer is 2 root 3. Good. Units. Oh no, no units. They're not asking. Now you can't do question 7 because that is logs. So forget 7 and 8, you can't do. So it's not hard. You know what to do now? dy dx. So you're differentiating that. So differentiate that. That is exercise 3E, question 7H. And 7D, you know how to differentiate something like this? Sine 1 on x. So how do you differentiate x to the half? What do you do? Aha, I'm glad I'm doing this one. Think, think, think. What's the rule? The rule is tan of ax plus b, isn't it? Or no, is it? No, it's tan function of x. The rule is tan function of x. But the integrals are only the ax plus b. So the rule is, this is on your formula sheet, if y equals tan function of x, then y dashed is f dashed x tan function of x. So with differentiating, you can do anything, girls. You can differentiate any sort of other function in there. X squareds, cubes, anything. But with the integrating, you only integrate the sine ax plus b. It's on your formula sheet, just be careful, all right? So what do you get? Well, that's your function. Yep. a half x to the... no. Girl, now you are half... Yep. So girls, differentiate to the negative a half times... And I shouldn't have written that. That was sec squared, by the way. So if y is tan function of x, y dashed is f dashed x, sec squared x. What do I write? Sec squared or just root x. Okay? So rewriting that, how does it look? So if y is tan of x to the half, you do your sec squared x to the half or root x, and then you differentiate that. And how do you write that nicely? 1 over 2 root x sec squared root x. You can try the next one. Just got to be careful with those. Try and differentiate y equals sine 1 on x. The trick's your first step. You could have written x to the half there and then written root x. How do you differentiate y equals sine 1 on x? Yeah, just make it x to the negative 1. Differentiate sine and you get, what's the rule? You get cos x to the negative 1 or 1 on x times what? Differentiating, what do you get? I'm trying to differentiate that. What do you do when you differentiate? Oh, yeah. No. That is differentiating sine of function of x. Look at your formula sheet. If you differentiate sine of function of x, you get cos of that times. If it was differentiating sine of x, you get cos of x. So you're differentiating sine of 1 on x, you get cos of 1 on x. But what do you do with the function? You differentiate it. So what do you get when you differentiate x to the negative 1? Negative 1, bring the power to the front, x to the negative 2. Now, how do I write that nicely? On x squared cos 1 on x. Look, I just didn't want to write here x to the minus 1 because I'm going to rewrite it this way. All right, what about if you differentiate, try question 8. C, if y is sine e to the 2x, differentiate it. dy dx. Well, it's if y equals sine function of x, then dy dx is f dashed x 9c. You know how to do it? All right, so you'll get the cos e to the 2x, but then what do? Then you differentiate the function. What do you get when you differentiate e to the 2x? 2e to the 2x. So it's 2. So when you differentiate e to the 2x, you get 2e to the 2x. Because when you differentiate e to the function of x, you write out the same thing, but then you differentiate that bit at the top. So you get 2e to the 2x cos e to the 2x. You right? Oh, you don't have to, but I think it was written with brackets. It was. Yeah. Can I move? We can't do the logs yet. I want you to differentiate. Have I got someone's whole notepad? Differentiate both these. Just making sure you know the difference. I want you to differentiate both those. Trying to trick you. Yes, you can. Differentiate, they're not the same question. Differentiate, all right, these are question 7A and the other one I made up. I want you to differentiate both those. They are different. How do you differentiate those? The first one is sine of function of x. You know what to do with the first one? Girls, this is what's going to happen in the exam. All these different types are going to be thrown at you, all mixed up. All right? The exam's probably not going to be that hard, but it'll be tricky because everything's mixed in. What do we do? That is sine of function of x. Well, you get cos, but then what do? Differentiate the x squared to 2x. So it's 2x cos x squared. So you differentiate sine, you get cos, but you're differentiating sine of the function, so you differentiate the function. But what about the next one? What does sine squared x mean? Sine x all squared. So you're sort of going back to what we did last year. If you had something squared, how would you differentiate it? You do 2, you write it out, you drop the power by 1, times differentiate what's inside. So this, on your formula sheet, is not really there. You're okay, girls? So with these squared ones, with the sine and that, you've got to be very careful. 2 sine x to the 1 times differentiate sine and you get cos. Now, that's 2 sine x cos x. Do you know that result from 2 unit? From 3 unit? That's actually the double angle result. But if you are in a 2 unit exam, you don't have to know it. But it is sine of 2x. But that's 3 unit. 3 unit, you don't need to do it. You would just leave it there. Now, I'll just give you a couple of questions from these. Just a couple. I think I already outlined which questions. All right. I'm going to give you a couple from those few exercises. Differentiating and integrating. So, here we go. Exercise 3E. I've given you a couple already. I might just make you do question 7F. It's good revision, girls. Question 9M. Exercise 3E, also question 11, that'll do. 3F. So these are applications of differentiation, so it's good revision. Just think of this as revision. I would do question, equation of tangent and normal to curve. I would just do question 6. And we can do one question on stationary points and inflections. 6 and 8. That'll do. I don't know if I set, and I did some 3G. Yes. I want you to look at 3G, just question 9. It's a very simple one-line answer. And I've set 3H, which... Actually, can we do a little bit more than that? Can we do 9C as well? 11, 12B, 14. It's revision. Think of it as revision. And 18. This is going to take some time. 3F question 8. It's a stationary point inflection, one of those. I hope it's not a horrible one. Now that is good to mix them up because differentiating, integrating. We start logs tomorrow. And then we'll finish off so that way you're doing some of these.
What if it says plus the graphs? What do you do?
Oh, I've done it in the video. I've done it in the, have you not watched the videos from last week? 5 point, do a table of eights. I think so.
Are we in A9 or M7?
No. Can you just look at your top? Is that Miss?
We're in
yeah,
A10.
we're in A10. Look, you know when it's 0, when they're both 0, aren't they both 0? So the addition of the two
0.
is 0. Look here, when it's pi and 2, I'd just be choosing some values quite. Isn't this one 0 and that one's 1? So is that, which one's which curve? That's 0 and that's 1, so the addition is 1. Now here, that is 1 plus more. I think that's 1 on root 2 there.
How do you know? How does?
Because it's sine pi and 4. So that, at pi and 4, the 2x is 1. And the other one, sine, is 1 on root 2. So it's 1 plus 1 on root 2. It's about 1.7. That point we did. This
Just
point,
keep doing tables.
yeah. And here they cross at 0 again at, what's this value, pi? So you got 3/4, you got pi,
2 pi.
you got
Oh,
zeros.
5 pi on 2.
Yeah. So you just keep going. 5
And
pi
then you
on-
just plot them onto the graph.
So there'll be points where it, yeah.
Okay, so you know for this,
Oh.